Hello, hello. Welcome to the DBA Fundamentals Virtual Chapter. We are here today with Gail Shaw, and she's going to do her session on GoGo Query Store. I'm very, very excited. It's going to be awesome. Just a couple of things first. As you can see on the presentation slide here, I have quite a bit of information there, but we have 5 organizers, Steve, Shane, Warwick, Kevin, and myself. I am Glenda Gable, your host and moderator today. All of our Twitter information is there, but also the group has a Twitter at DBA Fund. So make sure you look for that and check us out and talk to us too. So we try to advertise our sessions quite a bit on there and such, so some good information. Also, the website itself, dbafund.org. You can look at a list of all of our upcoming presentations. I believe we're running the year out with some really great ones, so definitely check it out. I believe Paul Randall's coming up and Bert Wagner, and we just have a whole bunch. So this presentation, as well as the last 4 years worth, are all in one place. You can check them out on YouTube. It's youtube.com/user/SQLPathTV. And they've actually done a great thing with that by putting all of the content from all of the virtual chapters in one place for you. So all of the presentations done for the architecture side and the performance side and the high availability side and everything, it's all one place. You can also check us out on Slack. We have our own channel. Excuse me, goodness. We have our own channel, so come on in and talk with us. We're also on LinkedIn, so check with us out and get in the DBA Fundamentals group there. It's a great place for networking, all of that. We do have a couple of sponsors, and they're the ones that really, really help bring us all this great content. We have world-renowned speakers every year for you, just like Gail Shaw today. Our main sponsor is SentryOne, and they actually have a lot of information for you. So here's their website information, Facebook, Twitter, LinkedIn as well. And they have a lot of helpful articles. They have one page with the helpful resources, which just is a lot of links to a whole lot of different places. So rather than list all the different links they have, they just have, in this slide, I just put the one resources page they have that just has all the links. So definitely check out the resources link. They also offer free query tuning advice, and you can get free trials of their software. You could also get the free Plan Explorer. I actually personally use it too, so it's really, really great. It's a plugin for Management Studio. You don't have to go anywhere else or open anything else up. You can just look at it right through there. Our next sponsor is DB Watch, and they have an entire complete solution for database administration, monitoring, performance tuning, security, and license management. Every time I say that, I think lions and tigers and bears, oh my, they just have everything. Check them out online, again, Twitter and Facebook as well. And they have a lot of different articles and things in their blog, so definitely look at that. But you can also get a free trial of their software as well. So check them out at dbwatch.com. We are an affiliate of the PASS group, and there are many, many virtual groups out there. So check them out. This is just listing them all for you between data science, administration, fundamentals, which is where we are, BI, performance, high availability disaster recovery, and even some non-technical. So you're looking at professional development, women technology. There's just a whole gambit. So check out all of them. There are, all of them have sessions, I think almost every month, if not maybe even more than. So check them out and see what you need, and there's going to be something out there for you. Come on, next slide. There we go. Another great thing about PASS is they actually help organize SQL Saturdays, and these are free one-day training sessions hopefully local to you. I wasn't aware of them until 2012, and let me tell you, I just was like a kid in a candy store when I went to my first one. It was amazing. It's a great way of networking. You have the same type of user community being the speakers as well. Every once in a while, you'll see some vendors in there, especially like at the lunchtime. But in general, you're looking at, you may see Gail Shaw at one, who knows? But
Actually, I'm
oh,
speaking in Joburg and Cape Town.
awesome. See, there you go. Cape Town. There we go.
903 and 897, Johannesburg and Cape Town in September.
Perfect. So see, it's an awesome way of meeting some of the people you hear online and meeting new people as well. It's been really great. One of the big things I learned when I went to my first one was I really broadened my network quite a bit in SQL Server. So if I have a question and I have a really bad problem or something, I am probably going to go to one of the contacts that I actually ended up meeting at my first SQL Saturday. So it's really, really great. And it's free. Woohoo! Another event that PASS actually puts on is the PASS Summit. It's a yearly large conference. And if you're looking at going, we can offer you $150 off by using our code. So check out our discount code. It's the big green letters and numbers. It actually takes $150 off. So the discount price right now is $2,059. And I think mid-September, I think like the 14th or something like that, it's going to actually do another increase. So if you're wanting to get in, make sure you get in now at the discounted price. Otherwise, it'll go up. And I'm not sure if it goes up one more time before the event or not. But there's all the information for you. Come on, advance and slide. All right, well, then last slide just shows that it's going to be recorded and you'll be able to get to it on YouTube at youtube.com/user/SQLPassTV. All right, so I'm gonna go ahead and pass it over to Gail. Let me make you the presenter and the rest of the time is yours.
Awesome. All right, good evening, everybody. It's 6 o'clock on a, well, spring-ish evening. And I've got a cat that insists on being fussed before I start speaking to anybody. All right, so if you hear any odd noises, it's probably the cat. Thank you, and the cat meows. All right, so Query Store. Normally I do this as a fairly interactive presentation, but since it's a little hard to be interactive on a virtual session, I'll try and manage without that. We'll see how this goes. So Query Store. What we're going to look at in this session is some common problems that we used to have around database performance. And these problems are not the type of, how do I fix this performance problem? They're more along the lines of, how do I identify this performance problem? And these problems were actually quite hard to solve. I'm going to show you how Query Store solves these. And then we're going to have a look underneath the hood and see how Query Store works and look at some of the system views that it has. So if you don't like the built-in report, you can go and write your own. All right, so firstly, have you ever wondered what the longest running query in your workload is? This sounds like an easy problem, but it's not. Because to answer this, you need to essentially have an extended event session, and please don't use SQL Trace any longer, it's ancient and deprecated, and query stores and, extended events are way better. But if you want to know what the longest running query in your system is, you need an extended event session. How long does the extended event session run? Well, basically, how long do you want to monitor for? Because that's the problem here. Extended event sessions start and stop. They don't run continuously. They capture a huge amount of data. You don't want them to run continuously. And so to identify what the longest running query is, you need to define over what period. You need to capture data, and then you need to analyze it. Same thing with the second question. On aggregate, what queries use the most CPU? This can be very important, especially if your system is heading or close to a CPU bottleneck. If your server is sitting 70–80% CPU all the time, you want to know what queries to tune to get that CPU usage down. But this isn't the queries that use the most CPU for a single execution. They can be the queries that are running very frequently. A system that I worked on a couple of years ago was running about 60–70% CPU on average. Not too bad, but the business wanted to triple the load in the next 6 months. Well, that doesn't work. You can't triple 70% and still have it under 100. And so they wanted me to do some quick tuning on their system. And after some analysis, what I found is that the query that used the most CPU was a little thing that ran in 20 milliseconds and ran about 1,000 times a second. It ran so frequently that when you added up its CPU usage over a couple of hours, it was an order of magnitude above anything else on the server. But this took analysis. This required an extended event session to run all day, required me to take that data, import it, aggregate it, and have a look at it. It wasn't obvious to them looking at the system views, system exec requests and that kind. Because when they looked at what was currently running on the system, yes, certainly they saw that little query, but it's running in like 20 milliseconds. It can't possibly be the problem. It was the problem, but it wasn't obvious. So these two questions are quite common. They're typically the kind of things that managers want to know when when the applications have performance problems, and they're not ones that you can typically answer without setting up an extended event session. If somebody comes and says, what are these? The answer is, I'll tell you in a week's time. And even then, you're only looking at over that week. Even more fun, somebody comes and says, this query is slow. And the query is indeed running quite slowly. How was it running yesterday? Unless you had an extended event session running yesterday, that question is impossible to answer. At least before Query Store it was. Because SQL Server doesn't keep track of that information. Let me rephrase that. SQL Server didn't used to keep track of that information. All of the system views are current data. All of the plans in cache are current plans. And so the question of how was this running yesterday is, I have absolutely no bloody clue. I hope we had an extended event session. Because if we didn't have one running, the answer to that is, I have absolutely no bloody clue. Let me know when it runs slowly again. Hopefully I'll have thought to put a trace on and see how it was running the day before. That's a really annoying problem, especially when you get called in to help tune a system and something is slow. It was fast 3 days ago, says the user, but we rebooted the server since then, and yeah, all useful information has gone, and I'm sitting guessing. And yes, I've had that problem. I had an insurance company call me one day, panic, crisis, this particular web page is slow. Can you fix it? Well, no, because I couldn't figure out what had happened. I could see it was slow, but I had no idea why, because I couldn't see what had changed from 2 days ago, because they had indeed rebooted the server and lost all useful information. What weights has this query experienced? That's an insanely hard question, because this one isn't even a wait, an extended event session answering question. This requires that you poll system views, specifically the DMV, which tracks wait information per query. Oh, by the way, that's transient. The data goes away when the query finishes. It's the current wait that the query is experiencing. So you need to poll that, oh, I don't know, 10 or 20 times a second if you want to know about that query, and that's just going to kill your server. So what waits has this query experienced? I have absolutely no clue. How about we run it now? I watch it while it runs. Oh, but it's not behaving the same way today as it was yesterday. What was it behaving like yesterday? I don't know. I can't tell. Horribly difficult questions. This is a fun one. What is the busiest time of the day? You'd think it's obvious, but I've several times asked clients this, because I want to take an extended event session over the busiest time of the day and have them just stare back at me blankly because they have no idea. They don't monitor the CPU on the system. They don't have any third-party monitoring. They don't watch the system. And so what's the busiest time of the day is it's probably around 10 o'clock, maybe 2 o'clock. Oh, but what about that peak load at 3 in the afternoon? And is Friday busier than Tuesday? No, typically Friday isn't busier than Tuesday, but that's just an overall trend. This can be kind of hard, because to find this out, you need to have been running extended event sessions for days and aggregate them on a daily basis and have a look at your stats. And really, most people don't do that. Even more fun, has my overall resource usage changed over the last month? Also known as, do I need to upgrade my hardware before my system runs out of resources? Or do I need to do it this month, or can we put that off for 3 or 4 months' time? How close to maxed out are we? This one requires extended event sessions running over months. Frankly, no one does this, at least no one I've encountered. Third-party monitoring tools might have enough information on this. If you take long-running Perfmon counters, you might know this, but overall, not really. And ask this of a client, and I'm pretty much guaranteed that I'm going to have blank stares in my general direction. So those are some common problems that I used to have, or still in fact have, working with clients, because unfortunately most of my clients are not on SQL Server 2016 yet. I had the pleasure of encountering a SQL 2008 R2 instance last week. Yeah, it's out of support. That doesn't mean it doesn't exist. So all of these questions can be answered with Query Store, which was introduced in SQL Server 2016. Query Store has been described as a flat data record of SQL Server query performance. It automatically, in the background, captures execution characteristics for queries and stores them in an aggregated form in the user database. They're not stored in memory. They're not stored in some weird random location. They're stored in the user database, which means they are persisted, which means if you restart the server, you don't lose all of this information. You certainly used to with, well, you certainly do with DMVs. If traces write to disk, which is fine, but if you're monitoring the DMVs, that's memory only. Reboot the server, all of that's gone. So let's have a look at how Query Store answers these questions. So what is the longest running query? Well, I've had a bunch of queries running against my database for a day or so. I couldn't exactly get people to hammer this database, so I've got some little applications which just sit and run queries. Let's go and have a look at Management Studio. So what is the longest running query? Which query over the last 24 hours has the highest maximum duration? This is a fun one. I often tell people, start your stopwatches. Let's see how long this takes me to figure out. We did say over the last day. So last day, and there we go. What was that, 30 seconds? I challenge you to do this with extended events in anything under, a week and a couple of hours of analysis. Admittedly, I turned Query Store on last few days ago, so we have this information. But I can see here that this particular query has the highest individual duration. It runs at most in 6.5 seconds. It is a stored procedure. There is its code. And more importantly, there at the bottom is the execution plan of the query, and it is a single query in the stored procedure. It is unfortunately an estimated plan, but that's because we couldn't possibly store the actual execution plan for every single query running on the system. So that was pretty easy. There's a built-in report, resource consumers. This report will show you over the period you want to see what queries consume the most resources. You can look at duration, CPU, logical reads, and a whole bunch of other things. I find most of these are not all that useful. I typically don't care what's doing logical writes unless I'm tracking something strange down. Looking at what queries have the highest DOP, I don't know. I can't think of a case I'd want that. Maybe, but you have it. So execute duration in milliseconds, CPU time in milliseconds, reads and writes, logical, in kilobytes, physical reads in kilobytes, and thank heaven they're not measuring them in pages any longer. CLR time, common language runtime. If you've got CLR code running in your database, how long did your query spend on CLR time in milliseconds? DOP is the degree of parallelism. Memory consumption, how much memory did my queries consume? If you're getting resource semaphore weights for memory grants, you might want to have a look at this to see what queries are consuming the most memory. Which queries are returning the highest amount of data? Which ones are using the most transaction log? Oh, thank heaven. How often have we wondered what filled my transaction log up? The answer has always been, hey, like hell we know. Good luck, try guessing. No, I can go and have a look at this. Which queries used the most log space? Which queries used the most tempdb? Which queries had the highest wait time? I should point out this is the SQL 2017 version of Management Studio, and I'm running in Management Studio 17.4. I'm way behind. SQL 2016 has less information. It doesn't have the wait time. It doesn't have a bunch of these as well. So those are the metrics you can measure. You can look at average, max, min, standard deviation, or the total. I'm not sure why I want the minimum. I can't think too many of these would be useful with a minimum, but again, I'm sure someone can figure out something useful. Average, on average, which queries are running the longest? This one, honestly, not as useful as it may sound, but it does help you identify outliers. This query that I identified as the longest running runs on average in 2 seconds, but had one execution at 6.5. So I've got an outlier here. This might be important, or it might not. Max, min, we've talked about. Standard deviation, that gives you an idea of the spread of the data. Is the query always running in 2 milliseconds, or is the query running in anything from 2 milliseconds to 300 seconds? This will give you an idea of how distributed your execution characteristics are. And then total. So my question of which query is using in total the most CPU, well, there's the answer to that. And it's not the same query. It's a very different query. This looks like Entity Framework, in fact. Project 2, yeah, that's Entity Framework. And I can see that it's been running an awful lot with a single execution plan. And on average, sorry, in total, over 12 hours, this has consumed twice as much CPU as anything else. So if I was tuning this system for CPU usage, I wouldn't be looking at this. Let's get client transaction store procedure, because while it is high, it's an outlier. I'd be looking at this query because on aggregate, it's using more CPU than the other one is. So that was those two questions. Oh, sure. Let me show you the configuration methods. If the drop-downs aren't interesting enough, there's all of the resources you can look at. Any time interval you like up to the last year. Most times Query Store won't have a year's data. It does remove old data, but you can go and select anything you like. Last day, please, and how many you want to return. So that's Query Store report for highest resource consuming queries, longest running queries, highest CPU consuming queries on aggregate. We got any questions on this at this point?
Not yet. You're doing great.
Well, either everybody's asleep or I'm being very clear. I don't know which it is. Let's carry on then. How was this query running yesterday? Oh my goodness. How was it running yesterday? Well, let's have a look at this one. This is query 43. You'll note that I've got a query ID here at the top. That's the query's information in Query Store. So let me kill this one and go and have a look at a particular query I want to look at. That was query, what, 43, I think it was. How was it running over the last day? Well, there's my answer. That's its average duration. Let's look at its total CPU usage. One annoyance here, you've got to enter the query ID every single time because apparently Management Studio doesn't remember. Oh, that's interesting. At 12 o'clock today, suddenly the CPU consumption of this query doubled. I wonder why. Well, in this case, I know why. I started a second application running queries against my database, but if this was a real system, that would be very interesting. Why did this query jump in CPU usage at 12 o'clock? Note it's not a different execution plan. It's only got a single plan. And that's the other interesting thing we can see here. We can see how many plans this query had. Is the change in execution characteristics indicative of plan change? No, it's not. Well, let's have a look at some other things. Did its average CPU consumption change? No, it didn't. In fact, it dropped slightly. So its average hasn't changed. The plan is consistent. So if the total CPU consumption has doubled, I must conclude that twice as many of these queries are running against the system as were running earlier. This is going to give me an idea of how frequently things are running. I probably could find that. Now, I don't have execution counts in here, but I will note that you can get that out of the system views themselves. Oh yes, and you can get this to auto refresh as well. So if I wanted to, I could have this auto refresh, and then every 5 seconds, it regenerates this report, and I can keep an eye on how my queries are running. I wouldn't suggest doing this for a lot of queries. That refresh is going to put load on your system. But if you try to keep an eye on a particular query, yeah, absolutely. Again, this would have been impossible to answer any other way. Well, nearly impossible, unless you had extended event sessions. Let me go back to my resource consuming queries. And I want this one, that is query 78. Nope, wrong query. Sorry, apologies for this one. Yeah, it is 78. No, I just got something else wrong. All right, so let's go to configure and do this the full-on way. 78, I want queries for the last day, and let's have a look at this. Very strange. Because I know this thing had multiple plans. Weird. If I go back here and I have a look at this one, sorry, I'm forgetting to change my data here. I have a feeling I've hit the max on Query Store and it's throwing data away. Because earlier this query actually had 2 plans. And I could have a look at both plans here and see how it was running. Never mind, I think I can probably fake that right now. There we go. All right, so let's go back to my track queries. Yeah. Okay, so I can see that I've got, for this particular query, I've got 2 execution plans. And one execution plan has some very interesting characteristics. It's going quite high in terms of duration, which is what I'm looking at here. Let's have a look at max CPU usage. Yeah, I can see that this this plan 85 is definitely a problem because it's way up. If I go and look at the second plan, it's plan 106, it's a lot better. Now, I could sit here and have a look at these and try to eyeball what the differences are, but this is a pain in the neck to actually sit and have a look at. So have some magic. Compare the execution plans, and it shows me which parts of the plans are the same. The clustered index econ clients and the clustered index scan on transactions are identical. The rest of the plan is different. Pull up the properties, and I get two sets of properties with what's different between them. So where's my problem in this query? Well, I can see I've got an estimated row count problem, 26,000 versus 1. I've got a parameter sniffing problem. This would have been insanely difficult to identify with extended events because I don't typically keep track of the execution plans as well. This would have required going backwards and forwards 3 or 4 times with different pieces, with different types of analysis to try and figure out what's going on with this query. Why is it performing weirdly? Does it have multiple plans? If so, what's the problem? I just essentially solved a case of bad parameter sniffing here, where in the past, it's taken me 3 days to figure out that a query had a bad parameter sniffing problem. And I'm not joking. That was with a client in Cape Town. That was not exactly my best day. But it took us almost 3 days to figure out that the root cause of the intermittent performance problems was one query that suffered from bad parameter sniffing. Because we didn't have Query Store. We were working on SQL 2008 R2. All right, so how was this query running yesterday? Query Store, happily will show you that. What weights has this query incurred? Oh, fun. Before I actually go and show you how Query Store solves this, let me kill a few things quickly. If you wanted to see what weights a query was currently incurring, you would want it's not DMOS weight stats, because OS weight stats is aggregate for the server. You want OS weighting tasks, which is, oh, this is awesome. No, it's not. It's absolutely bloody difficult to read. And you'll also note that this is going to change as things are running on my server. So these are all system sessions, because system sessions are always posting weights. But if I had some queries which were actually waiting for other interesting things, like, this is always a fun one to demonstrate. Wait for 15 seconds, please. Now you can see that session 55 has a wait for wait type. Well, yes, of course it does. I told it to wait. But as soon as that 15 seconds is up, that's going to go away. And there it is, it's gone. So if I wanted to know what queries were posting what weights for what times, I would have to be polling this DMV frequently. Very, very frequently. Which, to be honest, I don't think I've ever done, because the amount of work required is utterly ridiculous. Normally, what I'll do is DM exec quests, look what's running. I don't want my system stuff, I want my other stuff. Why am I? That's interesting. These things are running so fast I can't even see them. There we are. And I do have a suspended session. It's been suspended for async network IO. Normally I just look here and eyeball it. Oh, this query is getting this weight. But again, without polling these DMVs for a long amount of time in detail, you're not going to get a proper picture. So let's go back and have a look at one of our queries. And 84 again. Nope, that's wrong one. 85. Yes, you're going to be remembering query numbers. I'm sorry. All right, query 85. What is its wait times been like? Let's have a look at this one. It waited for, well, it's not telling me what wait types I'm getting. So let me go back from there. take my overall, oops, sorry, wrong DMV. That's still a secret. Pretend you didn't see that one. Top resource consuming queries. Let's have a look at this one. I want to look at top resource consuming queries in terms of wait time. Which query is waiting the most? Oh, it's that piece of entity framework garbage. What's it waiting for most of the time? Network I/O. Well, that's probably fairly obvious. That's a client problem. The client's not consuming the data properly. It's also waiting for memory for 135 milliseconds, and this is in the last hour. Yep, time period in the last hour. So in the last hour, this incurred 10 seconds of network I/O wait, 135 milliseconds of memory wait, 46 milliseconds of CPU wait, for a total of 10.6 seconds. And if you had other weights, they would show up here. What you've got are the weight categories. If I can remember where these are stored. This is the raw DMV. There's some categories. This isn't the 300-400 types of weights that you get in SysDM OS weight stats, because storing that would be prohibitive. So there's categories instead. Buffer I/O is a wait for a page to be read into memory. That's the that's your page I/O latch weights. Network I/O, that's your async network I/O. CPU, that's your signal wait. Buffer I/O, we've got parallelism, there's your CMEM threads. Memory, this would be resource semaphore and a few others. So you can have a look at the categories that your queries had their weights in, and from that, figure out roughly where the problem is. And then you can start digging in more detail if there's something specific that you need to look at. So this is what kind of weights did my query incur, and how long has it been waiting for various things? Again, good luck getting this with the DMVs. Awesome as they are, it's just a pain in the damn neck to get. Do we have any questions at this point?
Yes, we do.
Okay.
How long does the query store keep data?
Okay, how long does the query store keep data? Please hold that question for later when I'm going to discuss retention, sizing, and a bunch of other configuration settings.
Perfect.
Coming later.
Can we capture parameters for ad hoc queries and stored procs in the query store?
Can we capture parameters? No, because this is aggregated. The thing here is that you don't want to incur a lot of overhead for query store. The idea is that this is lightweight, and you also don't want to store a lot of data. Again, lightweight. So no, we don't have parameter values, and we don't have constants. Well, constants, yes, probably. We don't have variables, we don't have parameters. You can go and do the usual, look at the execution plan. Let me find the one that has a problem. Oh yeah, it's this one. So here's the query that's got a parameter sniffing problem. And if I go and look at the parameters, the properties of my execution plan, I can see that I've got parameter list, client ID, and I can see that this was compiled with 56, and this was compiled with 2. Doesn't tell me what they were run with, but it's going to tell me what they were compiled with. And if I go back and have a look far enough back, I'll see why I've got a parameter sniffing problem. Because, actually, let me see if I can show you the parameter sniffing problem. Last day, duration, total, thank you. That's, nope, not that one. That one, nope. I'm still only seeing one plan for this. Oh, this is showing only the last hour, that's why, for some reason. Basically you can see the compile value of the parameters. You can't see what they were run with.
Okay. Just a couple more. Can you filter a minimum number of executions? For example, something that has run only once, they don't want to see.
Not in the reports, but the system tables are all there. You can go and run your own queries against the system tables. I'll show you the system tables at the end of this. You can write your own queries, file, and throw them up into Power BI, reporting services, reporting tool of your choice.
Okay. So can you look at the scope of just a database as well as separately the entire SQL Server?
So query store is per database. It is entirely and completely per database because it's stored within that database. If you want to do it for the server overall, you need to go and have a look at Query Store on all the databases on that server. You can't enable it in master, I think. I don't think you can enable it in the system databases. You can enable it in all the user databases and look at the data across all your databases. You can aggregate them. Again, Power BI reporting tool of your choice, but it's per database.
And does Query Store need to be configured for the first time so it can start collecting data?
Yes, it does. Again, hold that question. We're going to look at configuration in a few minutes' time.
Okay, you're good.
Okay, what's the busiest time of the day? Well, it's clearly 12 o'clock till 3 o'clock. Let's see. So before now, when I've had this question, it's been a case of monitor for a week and then do some analysis. Let's see how long this one takes me. Done. I'll refresh it. 12 o'clock through to 5 o'clock, quite clearly. But note that the 6 o'clock hour isn't finished, which is why this one's not showing a full bar and why it's lower. Of course, this is only high because I've got these things running. But that's how easy it is to find out when you've got heavy resource usage on your database. Execution count, how many things ran. Duration, for how long. CPU time, how much CPU did it consume. How much reads did they do from memory. With the reads, I can see, oh, and it takes me to that period. Let's go back there. With reads, I can see I had a slight increase between 4 and 5. If this was a production server, I might be interested in that, or I might not. It's really going to depend on what I'm analyzing. Oh, I want to see this over a month. I want to see how long. Well, not very interesting here because I only turned Query Store on a couple of days ago. And I haven't, this is my personal database. I don't do a lot of work in it, but here's your month's data. How's my resource usage changing over the course of a month? This will show you. This has, yeah, I can't even begin to tell you how awesome this is. The last time I had to do this kind of analysis, it took me a couple of weeks. And that was to do the analysis, not capture the data. Right, so that's showing off what Query Store can do. With the built-in reports, I will point out, and only the built-in reports so far. Let's see if there's any quick questions before I go on to configuring and the internals of Query Store.
Nothing new yet.
Nothing new. All right. So, enabling and configuring. By default, Query Store is disabled. I wish it wasn't. I wish it was on by default, but the truth is that Query Store does indeed have overhead. Not very high, typically. I've seen a problem once, but generally it's a very low overhead, and Microsoft is highly allergic to put to any on by default changes which cause performance problems. As you can imagine, they don't particularly like getting sued. So you have to turn it on. All you need to do is come into the Query Store tab of your database and turn requested mode to read-write. Let me see, I've probably got a few other databases on here. Test is likely to have Query Store disabled. Nope, test has got it enabled. Maybe my transaction demo has it disabled. Yep, so this is the default, how you will find Query Store on a new database. You want to turn off to read-write and apply. That's it. You don't need to restart anything. Query Store is now running. There are some things that you need to pay attention to. So, let's just go through this bit by bit. Go back to my actual database because it's more interesting. All right, so let me work down this from top to bottom. Read-write and read-write and read-only. If you turn Query Store to read-only, no new data gets added, but all of the data that's existing in Query Store will remain there. If you turn it off, everything is gone. If you turn Query Store off, everything's gone. If you don't want anything new captured, and there's certainly cases you might want that, turn it to read-only. If I'm doing analysis of a client's database, I'll typically take their backup, restore it, and switch their query store to read-only. Did anyone catch the significance of what I just said? I took a client's database off their production server, a backup of their database, restored it to an instance at my office, turned query store read-only, and looked at their query store data. Query store is in the user database. It's included in the backups, which means it's included in the restores, which means that you can take a copy of production somewhere else and do your analysis somewhere else. Data flush interval. How often does this go to disk? Query store goes to memory by default. In this case, it's flushing to disk every 5 minutes. The default is 15. The significance here is if SQL Server hard shuts down, I can lose up to 5 minutes of query store data. This probably is not a concern. The lower it is, the higher the background I/O usage is. But if you turn this to something like 30, you're going to see spikes of I/O as it flushes to disk. I like 5. Collection interval. Query store is aggregated on disk. Sorry, query store data is aggregated, full stop. At what resolution am I aggregating? By default, it's an hour. I always turn this down to 15 minutes because I want more granularity in my statistics information. This determines what the minimum you can see here is. You'll note that these are 15 minutes apart, even though my graph is 5 minutes apart. If my query store was set to 5 minutes, I'd have more pieces of data on that chart. Max size, this defaults to 100 megs. That is tiny. When query store fills up, once it reaches, I think it's 90% of its size, it will start throwing away old data, the oldest it has. If that happens to be 2 hours old, too bad. 2 hours is all you get. So you do need to size this for how long you want to retain your data in query store. If you want to retain for a year, you're going to need a lot more space than if you just wanted to retain for 2 days. It's going to depend on your database usage. It's going to depend on the frequency of your queries. It's going to depend on your statistics collection interval. The more granular this is, the more space will be consumed, which means you need to make the size larger. Capture mode, all or auto. All means all. Auto means that queries which are fast and don't run very often won't be captured until they pass a threshold. I like auto, to be honest, because I don't really care about these little select get dates that run. The default is all on the Earth SQL servers and auto for Azure. I often change it to auto even for normal SQL servers. Size-based cleanup mode. If this is auto, it does what I said. Once it reaches a certain size, or once it reaches 90% of max size, it'll start cleaning up data. If you turn this off, it will not clean up old data. It will not throw away old data. And when query store fills up, it switches read-only immediately. And you have to go in, clean up, and switch it back to read-write to get it to capture again. Stale query threshold. At what age do we start throwing data away? If you want to capture data for a year, you need to set that to 365. If you'd like to capture for a decade, I don't know what you're doing, but you can do that. So those are your query store settings. That's actually it. And then here you can see that my database is 2.4 gigs in size, and I've got 2 megs of query store in use. 398 megs are free. Purge does exactly what it says, throws everything away, use with caution. Any questions on configuring and enabling query store?
Yes, a couple. Does the query store size scale dynamically up to the max, or does it pre-allocate the max size right away?
So pre-allocate, they're tables in a user database. They're tables in your database. There's no pre-sizing. The size is simply how big those tables are allowed to get before it starts cleaning up. They're not files on disk. It's literally in your user database.
Awesome.
If I misunderstood, please ask that again, phrased differently.
And then is it possible to filter out maintenance task query out of the query store?
Is it possible to filter maintenance types? No, but keep in mind that query store is for a database. So if you're talking about SQL agent stuff, that's in MSDB. It'll never be in your user database. But no, that's typically the kind of thing that when you're reporting filter on, query store captures without any filtering. We don't want to have to configure it complicated. That's painful. Anything else?
That's it.
Okay, then quickly, because I make that I've got like 3 minutes left, let me show you some of the queries that you can run. I don't have anything fancy written, but I can show you what's in Query Store. So we saw the reports. Those built-in reports are fantastic. Sometimes you want more finicky stuff. You want to go and look for specific queries. You want to exclude things that are only run once, etc., etc., etc. So they are called sys.querystore, all of them. The table you want to start with is sys.querystore query. This has one row per query. This is similar to the query hash in the sense that queries of a similar form will be stored together. You've got the parameterization here, user, none, simple. You've got a whole bunch of information as to when it was first seen, last seen, most recently seen. How long does it take to compile? How much resources does it take to in its compilation process? If you're trying to debug what's taking a long time for compilation, this has got a whole pile of that information. Otherwise, it's mostly just a place to start. Let me go back to the presentation. So there's 5 tables, main tables, which Query Store has. They're here so that you can get this. So you've got this record. Let me show you what's in the rest of them. sys.querystore query. Sorry, sys.querystore query text has the text of the queries in it. This is a one-to-many. One query can have multiple texts because, again, things like query hash, you can have slightly different texts for the same query. It filters out white space and that kind of thing. But you can see the text of all the queries I've ever run against this database, or since Query Store was enabled, which means you can do things like what queries have run against my client database and work that back to the query IDs. Everything else in Query Store depends on the query IDs or the query plan IDs. Query text is the only place you can get the actual text, which tables it goes to. Right, next one down the hierarchy is sys.querystore plan. This has one row per plan per query. Oh, and look, here's the actual, here's the estimated execution plan. It's not the actual, it's not the runtime data, but it does have the full-on graphical execution plan in its XML format. Which version of the database this was for? What compatibility level? Apologies, that's my timer saying I'm out of time. Here's my query hash. Is it trivial? Is it parallel? Is it forced? Is it natively compiled? The question of what runs in parallel? Hell, I can now answer that because previously that required an unpleasant troll through the plan cache. When was this compiled? When was this compiled? When was it last executed? How long did it take to compile? Did we force it? Right, next down the list is, and this is the one that has the really, really interesting information in it, Query Store runtime stats. One row per plan per runtime stats interval. The stats interval is that 15-minute, 5-minute, hour grouping that I'd said about, and there's a runtime stats interval view that actually has the start and end times in it. When did this first execute in this interval? When did it last execute? How many times did it execute? There's your, I don't want to see things that have only run once. Duration, average, last, min, max, standard deviation. That's what all of the pieces of data have. CPU time, logical I/O. This is where the reports gets all of its information from. Logical writes, physical reads, CLR time, DOP, memory used. Yes, I'm still going. Row counts. How many rows did this query return? Physical IOs, log bytes used, tempdb space used. Note the weights are not in here. The weights are not in here because the weights are in somewhere else. The weights are in Query Store weight stats. One row per plan, per runtime stats interval, per weight category. Not necessarily, if it didn't incur the weights, it won't have a row for it. But I can go and see that this query in this interval had CPU, network I/O, and memory weights. And this is how much time it waited. So there's your, I don't like the reports, I want to go and ask more detailed questions. There are your main views, along with query store runtime stats interval, which, as I said, contains the start and the end times of each interval. So with those, you can write just about anything that you want to dig out of query store. I've before now trolled the query store for all sorts of information. I don't have any fancy queries against this, but hell, we're all DBAs, database developers. Have tables, we'll query. Right, so before I take final questions, some additional resources. Erin Stellato has written an absolute metric ton on Query Store. She loves this feature. You can find her blog at the top link and her Query Store posts in that category. If you want to listen to Connor Cunningham, and believe me, you want to listen to Connor Cunningham, he's awesome. He's also a principal architect for SQL Server. This is a few years old, but this is a SQL Bits session for Query Store when he initially introduced it. So again, it's a little on the old side, but it's a lovely presentation. It's completely free, as all the SQL Bits videos are. So go download, watch, and enjoy Connor for an hour. Then if you have Pluralsight access, and if you don't, I highly recommend Pluralsight. There are 2 courses on Query Store. SQL Server Query Store Introduction is by Erin Stellato again. She covers the details of Query Store. And then I've got a course on Query Store, Solving Real-World Problems, where I show how to do a bunch of things like parameter sniffing, upgrade tests, regression tests, all sorts of fun things with Query Store. Are there any other questions in the last 3 odd minutes before the top of the hour that I can answer?
Yes. If we have a query that joins tables from 2 different databases, will the query show up in the Query Store of both databases, or just one, or how does it show?
I have absolutely no idea. Gut feel is going to be in the one that the database was, that the use statement was in, so which database context you were in. But do feel free to test that out and let me know, because I actually have no idea.
Okay. And then the cleanup of old data, is there a stored procedure that does that? When,
no,
when it hits the threshold?
It's in the engine. It cleans itself up, so no, you can't go and change how it cleans up. This is built into the engine, which is why it's so fast. Okay. Unfortunately, there's very little knobs on Query Store. You can't do very much to change its behaviors. So we just take it as it is. Sorry.
Let's see. You indicated the execution plans are estimated and not actual. The question is there a way that the actual plans can be captured so that we can refer to them later?
No, way too expensive. Consider that every single execution has a different actual plan. Query Store is aggregated. There is absolutely no way it could get the actual plans in. I really wish it did. It doesn't. SQL 2019 has a new dynamic management function, which returns the last actual plan for a query, but that's about the best you're going to get. Or a really expensive extended event session, which I strongly don't recommend. It's a pain in the neck, but it's pretty much, it's because there's so much data in that.
That makes sense. All right, that's it.
Okay.
Do you mind showing your contact information screen? Do you have an email address that you put out for people?
Whoops. Okay, well, let's, that's a problem. Okay, give me 2 seconds. This is called Hack the Slide Deck on the fly.
You have had several thank you very muches and great sessions and that kind of stuff. And I concur 100%, so.
Okay, we'll pretend that slide always existed. So all right, my blog, whoops.
Go ahead, perfect.
My blog is sqlinthewild.co.za. It's a little not updated lately. I'm really struggling to write, but I'm trying to get some stuff out. On Twitter, I'm at SQLintheWild. That's pretty much that. I'm on the Slack as well. Let me try. So the SQL Server Slack, I'm Oh, no. I can't type tonight. If you go to the SQL Server Slack, I'm Killer Monster. Long, old nickname. Whatever.
All right, so if you have any follow-up, there you go. And for the person who was going to test, make sure you let her know.
Please.
Yes. So somebody out here has homework.
Always a
All
risk
right,
asking
so
questions in a presentation. I might actually tell you to go figure it out yourself.
all right, so again, the recordings will be available within a day or two on youtube.com/user/SQL Pass TV. That's SQL Pass PASS TV. That's where everything is collected, and so it's kind of an automated thing ish. So thank you so much again, Gail. I know you've had several comments. A great job, all that kind of stuff. I concur 100%. This is a great session. I learned quite a bit myself. Which is one of the reasons I work with all this. I get to see all the sessions. So if you need anything else from us, we are online. You can get to us at dbafun.org, see all the sessions that are coming up. You can also get to us on Twitter at dbafun. Also LinkedIn, we're on that as a group. I don't know what the number is to get to the URL, but our information's out there, and you can also look at the intro slide to this presentation when it's out there. So if you need anything else, let us know. Otherwise, don't forget to sign up for, if you're going to sign up for Pass Summit, you can use our discount code for a $150 discount. Have a great day, everybody.
Cheers, everyone.